kind of sad because the last day of a conference. Anyway, browser is the new server. I'm Gleb. You can find me everywhere under my last name. I come from Boston. It's our beautiful office in Harvard Square next to Harvard University. And I work at a company that answers questions like, how does cold weather affect price of bananas? Or anything against anything. So finds all the stats and finds all the correlations. And a couple of years ago, we wrote this Angular 1 web application. That's how our customers use us. And then we became a victim of our own success. Customers started asking how this huge set of events correspond to this huge set of prices. And so the web app became sluggish. If you know Angular 1, it's very easy to start, but it's kind of hard to scale as number of items grows. Angular 1 has performance problems. So I love performance problems, and we started solving them one by one, and then we would hit the next performance bottleneck, and then the next one, and we would solve them one by one. And I started writing this blog post explaining how we solve the performance problems. And at some point, if you actually Googled AngularJS performance, my blog post was #1 search result. And it still is #1 search result on the second page. And you're asking yourself, what does any of this have to do with Node.js? And I promise it will make sense soon. So when you talk about web performance, there are two parts. One, you have to actually start the app, the bootstrap. And the second, once it's running, you have to actually keep running it very quickly so it doesn't feel sluggish. It doesn't freeze as you interact with the page. And so we spend a lot of time optimizing the running part, and it's hard, right? You have to do everything in less than 16 milliseconds if you want to run at 60 frames per second. And so you can go to virtual DOM. You can even offload long-running operations to web workers. But I was really interested in something else. It's like, how do you actually start the application quickly? And not the first time you visit the page, but when you reload the page, when you come back to continue your work. And so the question is how to start a web app quickly. And this assumes that you already done the usual things, like serving of everything of CDN. You minified your JavaScript, your styles. You use small images, things like that. What do you do after that? So a typical page starts with just HTML. So the browser gets HTML, gets the JavaScript, the CSS. Then it has to probably parse and execute the framework. Could be React code, could be Angular code, whatever is your framework of choice. And then it actually grabs your application, starts executing the actual web application. The application gets the data, and finally it draws something on the screen. Now, you don't really have control over this, right? If you put your framework, your HTML on a CDN, that's as fast as it can go. You really control only this part, the application code, how it gets the data, and how it renders the data. Also, the browser probably caches all these resources. So once you get them, they're there. They're very quick on reload. You probably should cache the data so it's available right away the next time the app is restarted. And this part can be very, very expensive. The application by itself starts up, how it gets the data, how it renders the data. And the example that I want to show is this. I use PIVOTALTRACKER, which is just a huge to-do list. And here's a video of me not modifying anything and just reloading the page a couple times. And Wi-Fi. It's working. Yeah, it's doing something. Let's see if it's actually faster to load the PIVOTALTRACKER itself. OK. So I'm just reloading the page, and you can see that there is an initial delay, there is a loader, and then the app actually appears. And I'm reloading again. I have not modified anything, right? It's just my own personal to-do list. And yet it takes a couple seconds just to load this web app, and for the web app to display the to-do list that hasn't changed. And so this brings the question, why am I waiting a couple seconds? Like, my data hasn't changed. It's not like it's Twitter where the new tweets came in, right? This is my personal private data. I have not modified it. And also, as a human being, I cannot interact with a page that quickly. So the first couple seconds, I probably will just look at the page, and I'll read the to-do items, but I cannot possibly interact quickly enough in the first, let's say, half a second. And so I opened Chrome DevTools, and I profiled the page load. So I want to see why it takes so long to actually start and for me to see something. And I noticed something right away. They put their company logo and PIVOTALTRACKER name in ASCII art in a console, and I like this. This is really nice. And they actually spent a lot of time because they even drew the shadows right here. I like it. What I didn't like is that it spent almost 5 seconds, and this was a couple of months ago. I think they optimized it now. They spent 5 seconds just executing JavaScript. That means the framework, the app itself. That's way too long. At this point, they actually were loading both Backbone and React, so they were transitioning. So there's a lot of JavaScript. Even more frustrating than this is this fact. So usually you load initial HTML, which kind of is like header, empty div, where the web app will live, and then the footer. When application starts, application loads the data, updates something, and boom, all of a sudden you see like violent transition where the content comes in. Usually you put a loader to hide this, but if you don't, you will see this sudden shift in content. And if you're trying to, for example, to interact or read something, all of a sudden you lose your page, your place on a page, everything shifts. If you're trying to click something, all of a sudden you click at something else. So let's look at this. Again, app loads the data, renders HTML. So you can say that the HTML that you render is kind of like a function of the data. And if your data is the same, if you just reload the page, it's the same data, it should generate the same HTML. So that was my initial idea, that if we cache the application code and we cache the initial data, we should actually cache the HTML, because we'll just recreate the same thing. So imagine we load the application, it updates the page, and we save both the data and the rendered HTML in a local storage. Next time we load, we'll load HTML from local storage, and we can display it right away. And then we can continue loading normally. So I wrote something like this that I call hydration. And let me see if I can just show it live. OK, so there is web application. An application only starts after a couple seconds. But you can see that the to-do list, that's quite long, appears right away. It was cached. And while the web app is loading, I'm seeing the static snapshot of HTML. And I can interact once the web app loads. I can add new to-do. And if I reload, it's right there. I don't have to wait for actual web application to start to actually see my to-do list. So I call this hydration. And I think we lost signal for some reason. I apologize, but can we get some technical help? Just went blank. There. Yeah. That was weird. Thank you. As always, rebooting everything helps. Microsoft. So I call this hydration. It's a single little library. It works with any framework because it doesn't really care. It only cares about storing data and HTML. And all you have to do, you include a single script tag right after your div. And it has only 2 functions. So the API is very small. And when HTML loads, this hydration library loads the cached snapshot if it's available, shows it right away, and then creates an empty hidden div for the actual web app to start behind the scenes. So your app can actually render HTML, but in a hidden thing, while the user sees a static snapshot. And then when it's ready, you just execute a function, and you switch to live web app. And this happens really, really quickly. And that's what I call progressive apps for 5 cents. Works pretty well. I'm I moved my website to this. But there is a tiny problem. There is a tiny, tiny little flash that happens when you actually load the page. And I have a video to show that. And basically, it's because the local storage get operation is synchronous. And then you put this snapshot into your DOM. And this makes the page self-rewriting. And I have a video to show this. It's not actually that noticeable in modern browsers, but you will see it kind of flicker right away. Did you see this, right? So the top of a page is static, right? So this loads right away when you reload the app. But this one will come from local storage. And that tiny flash was really annoying. I really hated it. And so I needed a better solution. Because if you used to server-side rendering, right, like this to-do app, I can reload the page, and there is absolutely no flash. Like, I'm reloading this page many, many times. The whole page arrives as a single static HTML. And as you can see, the browser is really good at rendering this. The whole page just appears. You can throw like a megabyte of static HTML with a bunch of styles, and it will appear as a single page very quickly. The only thing that's really slowing the browser and is causing all these flashes and the frustration is our JavaScript. The real JavaScript fatigue is right here, not in the browser. So I was thinking, I cannot give a browser part of a page and then rewrite the rest. That causes a flash. But I can give a browser the full page, the full HTML, and it will appear instantaneously. How can I give the best of both worlds, combine the output of a server with my live content that's available in a browser, but as a single page? And here's the new technology that just appeared maybe 2 years ago. And it's called Service Worker. Usually in a browser tab, you can open separate threads, and these are web workers. And you can offload long-running operations. But there is a new thing in town called Service Worker. And the Service Worker is a separate executing context. And the interesting thing about this is that it can act as a proxy. It can intercept the requests from the page. And it could be static resources, AJAX. It can transform the request, and it can pass it to the server, or even answer it itself. And when the response comes back, the service worker, acting as a proxy, can transform the response and then send it back. So usually people use it for offline support, for smart caching, right? Because it's JavaScript, so you can do whatever logic you want. But in my case, before we talk about adding it to the page is really simple. You just execute service worker register, and you provide the name of a script, so the browser will load it. And it's already available in Chrome, Firefox, Opera, and also the Chrome on Android. So mobile market also has it. There are certain limitations. Just because you intercept everything, you better be pretty sure that the service worker is from trusted source. So you have to use HTTPS. Inside, you have different events. You can control how it starts. You can send messages, just like a web worker. But for our purpose, the most interesting event is fetch. And fetch is when the page requests a resource, and then you can intercept and proxy and do something, the fetch event. The environment in Service Worker is very similar to web workers. You don't have access to the window or document, but you have asynchronous cache, you have IndexedDB. You only have fetch, HTML5 fetch. You don't even have the old XML HTTP request object anymore. But you have promises. You can post messages and communicate from the service worker back to the main tab. So the first thing I wrote was something I called bottle service. And the idea is this. What if the page sends the little fragment, the last snapshot of HTML, into the service worker? Just saves it. And then when you reload the page, the service worker can just go to the server directly, not doing anything. And the service worker, the server can respond with just kind of like the page outline that has header, footer, and a place for web app. So this gets back to the service worker, and the service worker can insert this cached fragment into this page, and then send back to the browser the full page as a single HTML snippet. All you have to do, really, react to the fetch event, go fetch the page, and then combine whatever you have and create HTML response yourself. And so here's how it looks. Let's see if it loads. So I have pretty large list of to-dos, and I can interact. I can add a new one. And if I reload the page, it appears instantaneously. Okay? Again, this is a web app, but because the page was created in a separate context, and when the browser received the full HTML, to me, this looks like server-side rendering. But in reality, this is a web app. So this is what's nice. I don't complain about anything, but this has a huge problem, right? If there is no Wi-Fi, or if Wi-Fi is kind of bad, like low-fi, maybe some resources loading, maybe our resources not loading, you get this. You get the dinosaur picture, everything is broken. If only there was a way to fix this. Because we got the full page appearing instantly because of server-side rendering, but if the server is unavailable, well, we're out of luck. But here's the interesting thing. So the browser goes through the service worker to the server and transforms the response. Inside the service worker, the objects that you get are HTML5 request response. Let's say you run Express.js or any Node.js server. So you use HTTP built-in client request, server response. Well, you're running JavaScript right here. You're running JavaScript right there. Well, you can take that server and just move it right inside the service worker. Nothing's stopping you. It's just JavaScript. And here's how it looks. All you have to do, you really have to adapt the request to whatever Express.js expects, and you have to adapt the response to whatever browser expects. So I went to NPM. I grabbed the two most popular projects, Browserify and Express, and I took my Express and all its middleware, or whatever else I was using, ran Browserify, and created something that could run inside service worker environment. There was a little bit of adjustment to make, just because usually the fetch API in a browser is not used to actually create requests. XML, HTTP was used, but you can adapt that. And I created something that is called Express Service. So you take any Express app, and then inside the fetch, you adapt the request to something that Express middleware understands, or you kind of fake it, you duck type it. And you also have to adapt the response, and then you respond to the fetch event by running through the Express middleware. And that's pretty much it. And let me show how it looks. Hi. Let me. Nice. Now, this is running on Express service glebdemos.com. And by now, you're probably thinking, OK, this is nice. This appears like a server-side rendering. This doesn't look like you're running it in your browser. So let's turn the Wi-Fi off. Right? Now let's play dangerously. OK. To do. OK, still works. So my application actually is not running on the server. Right? This is running right inside my browser. We can go even further, and we can say, OK, offline, just to be sure. OK, so now we're running in offline mode. And now, let's go back. Over the past 2 years, people were talking trash about JavaScript. Everyone says we have JavaScript fatigue, we hate JavaScript. OK, maybe I agree with that, maybe I don't. But let's just, as an experiment, go to settings, And let's disable our JavaScript, right? What do you think will happen? So right now, I have no Wi-Fi. I have no JavaScript. And my application still keeps working. You can see that. OK. Yeah, back normal. So the only connection I have outside world is the video cable, and that gives me problems. OK. So basically, here's what happens. We don't have Wi-Fi. We don't have JavaScript. But when you disable JavaScript, you actually disable the client side, not the service worker. Once the service worker is loaded, the page doesn't need JavaScript. If we look at the source for this page, it's exactly server-side rendering. It's just a big form. There is no client JavaScript. In fact, using content security policy, I completely disabled JavaScript just to prove that it's really server-side rendering. Let me turn the Wi-Fi back. There's a new way to actually load service worker. You don't even have to execute client-side JavaScript. You can load it using a link or even a header from the server. Now, as a bonus, if you like Electron apps, there's a project called Netifier that grabs any web application or static page and converts it into standalone Electron app. Except that Electron app still needs Wi-Fi, because it still goes back to the server. If you actually package something like this, like Express servers, you create offline Electron app, right? Because it works completely offline mode. Another thing, let's say I got your interest, right? Because both Mozilla and Google are working very hard on this technology. They think it's a way of the future to create progressive apps that can be installed and executed and compete with native apps. Definitely, you should check out Mozilla and a couple of people from Google who post a lot of blog posts, videos, and showcase this technology. I only have one concern, right? We kind of start writing JavaScript that can be executed or rendered both on a server and on a client. And we call it isomorphic. And then we realized that isomorphic makes no sense as a word, so we started calling it universal. So now we need a new word to actually describe a server that can jump from the server side all the way to the browser, right? Because we're not running identical code. We're actually moving the code over the gap. I think jumping is a good word, jumping JavaScript. What's that? Oh, damn. I don't know. I apologize for this. Excellent. So I think jumping JavaScript kind of has a nice ring to it. So that's my proposal. And this is my story. And I would love to discuss this technology and how Node.js can run inside the browser and for this kind of applications and for others. And I want to thank you for listening to me.